this video is looking at square numbers and how they relate to product of primes. So let's get started. We're going to look at what a square number is, have a think about what you think the definition is of a square number. Okay, so we know that when we square a number, we multiply it by itself. So an example of this is 11 squared, which is 11 multiplied by 11, which we know gives us 121. So this is the square number 121. It's the product of 11 squared. If you fill in the blanks for these two square numbers, okay, so you can see here this is going to be 6 squared is equal to 6 times 6, which is 36. There's a square number. And then 10 squared is 10 times 10, which is 100. So these are examples of square numbers because you multiplied something by itself to get the answer. Now take a moment to list all the square numbers from 1 to 100. So for example, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. What are the rest of the square numbers up until you get to 100 here? Pause the video, have a go. Okay, so hopefully you've got your list. I'm going to fill in the blanks for you here. We can see we should have 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, and 10 times 10 is 100. Right, these are all our square numbers up to 100. So 1 squared up to 10 squared. Now let's look at this in a bit more detail. I would like you to look at the list of square numbers down the side that you can see here and spend a moment after I say go, pause the video, and then show each of these numbers as a product of primes. So one example is 4 is 2 times 2 and 9 is 3 times 3. Work your way down the list and write all of these as product of primes. Pause the video and then I'm going to show you if you can spot a link. Alright, here we go. So here are my answers. There's a couple of extra examples I've done here as well. What I want you to look at is what is the link between all of these square numbers. When you write a square number as a product of primes, what do you notice about these products? These two extra examples are also quite useful just for you to spot. If you're not sure, I'll give you a hint. Consider the combinations of numbers, consider the colors, maybe that might make it easier for you to spot. Okay, so I'm going to tell you what it is now. In case you haven't spotted it, you may have noticed that these numbers tend to come in repeating pairs. And in this case, the order is not as nice in this case, but you can see that the 2's come together, the 3's come together, and then the 5's come together. So anytime you have a square number, you know that all of these square numbers will have, the way to phrase it here is, all square numbers have repeating factor pairs. So factor pairs that repeat. And it kind of makes sense that this is the case because, for example, in the case of 81, we know that's just going to be the same number multiplied by itself. And when you break down that same number, you're just going to get the same factor pairs eventually. So there's your pair, there's your pair. We know that these two numbers have to match because we're squaring. So the same applies to any of these. We're going to use this knowledge to work backwards and perhaps deal with bigger numbers. So let's do an example here. Express the following as product of prime. That was, don't know what that was. Okay, this slide here. All the following are square numbers. Fill in the blanks and use this information here, that all square numbers have repeating factor pairs. So the first one I'm going to do for you as an example. We know that if it's a square number, and in this case all of these numbers are square numbers, well, 2 has to have a factor pair. In this case, a repeating factor pair is going to be 2. Well, that has to be 3 times 3. So 3 is the only option in this case. Work your way through the rest and see if you can do that. And then I'm going to go through the answers with you in 3, 2, 1. Okay, so let's go through the answers. There's your factor pair, and then in this case that's going to have to be a 2. 3 times 5, well, we're going to have another 3 times 5 as well. 3 times 29 times 29, well, this is your factor pair, and then that means that's going to have to be a 3 because they're going to have to go together. This one here, well, 5 needs to be repeated, and we can see the 2 is already repeated, so there has to be a 3. Now you may have got those the other way around. It's still correct. The commutative law of multiplication applies here, so the order doesn't really matter. And then finally here, there's a factor pair, repeating pair. There's a repeating pair. Now in this case, any number, as long as it's the same, can go here. So you may have put a 7 and a 7, or a 50 and a 50, or a 13 and a 13, doesn't matter. Infinite number of answers, any number. Okay, level 2 exercise. Try to fill in the blanks for these. Pause the video and then I'm going to go through these with you. Okay, now here come the answers. So 6, now remember this actually isn't written as a product of primes because 6 is not a prime number. So we know that another way to write this is blank times, now rather than 6 I'm going to write 2 times 3 times blank. And that means that one of these has to be 2, one of these has to be 3. You may have done this in a different order, but that's one possible answer. Okay, the next one, we've got a 9, 2 and 3. Well, the 2 has to have a factor pair and the 3 has to have a factor pair. And actually here, these don't have to be prime numbers because they're not product of primes. So here it's just going to be 9. There are, in some of these questions, there are other possible answers, but we're going to stick with the simple options. So 7 has to have a factor pair. 13 has to have a factor pair. And then we've got 3 and 3, 5 and 5, 2, and then that has to be a 2. You may have written these 3 numbers in a different order. It doesn't matter as long as you wrote 7, 13 and 2. Those are your answers for this activity. Okay, now let's write the prime factor decomposition of these square numbers in an efficient way. Now if it's in an efficient way, we know, I'll do one example for you, 15 squared. We don't want to work out what 15 squared is or 45 squared. We can actually just use this as our clue. We know this is going to be 15 times 15, which is the same as 3 times 5 times 3 times 5. So that's your answer, 3 times 5 times 3 times 5. Have a go with the rest of the questions. Pause the video and I'm going to show you the answers in 3, 2, 1. So here are the answers to the other 2 questions. Have a quick check. Okay, I'll see you in the next video. Smash the like button.